Okay, so in this video, we want to create a derivative graph for a given function graph without knowing the actual function. So you see in this graph that we have here, it's a function labeled f. We don't know anything about f, so we can't take its derivative analytically and plot it. We have to figure out its derivative graph just from what we see. Now, when we graph derivatives, we want to start by looking if this function graph has any horizontal tangents. And right here, we see that a horizontal tangent exists around this location. So that means that the derivative graph is going to cross the x-axis here. I'll explain that in more detail in a moment. I just want to find the other horizontal tangent. So we expect the derivative graph to cross here as well. So why is that? Well, the derivative graph has the same x coordinates as the function, but the y coordinates of the derivative will be the slopes of the function. So here there's a slope of 0 at this location here. So since the slope is 0 here of the tangent line, that means we have an ordered pair here, let's say 5.2 comma 0. That is an ordered pair of the derivative graph. And since we have another horizontal tangent here, that's the slope, we have an ordered pair 0 comma 0. Again, the x-coordinate is the same as the x-coordinate for the graph of f, but the y-coordinates will be the slopes of the tangent lines. Now, I just want to highlight this section of the graph and notice that the graph is got a downward trend here. That means that all of these slopes along this part of the graph will have a negative value. So that means between our two values here, between this intercept and this intercept, all of the slope values in between will be negative. So I'm just going to look for a value here at 2. I'm going to put a point there. I want to find the slope. I'm going to take my ruler so that I can draw a tangent line here. And now I'm going to approximate this tangent line. So from this point here, this is about the midway between 1 and 2, and then to here. So if I count this, I'm going about 1.5 over, that's my delta x, and 3 down. So the slope for this location, we have an x-coordinate of 2, but the slope is 3 down over 1.5. Negative 3 over 1.5. So that looks like the coordinates are 2, negative 2. I'll put a point there. All right, I'm going to erase this just so that I can focus on my next point. So let's look at the slope at 3. So here we see we're at 3. If I bring my ruler back over and I draw my tangent line, it looks like I have 1.5 over, 1, 2, 3. So it looks like it's about the same slope. Again, it's negative, it's headed down. So I've got something that looks like that so far. Now, let's look at a value on this side where the slope is positive. Let's pick a point. I guess we can try negative 1. Put a plot on the graph. We'll draw our tangent line there. And if we count from here, it looks like it's 1, 2 up and 1 over. It's approximately a slope of positive 2. Again, we're just estimating here. Let's erase this out. So far, my derivative graph looks like this. And then on the right-hand side of this horizontal tangent, this is all positive as well. So we could evaluate it at 6. So we could say, well, what's the slope look like it's equal to there at 6? So it looks like it's 1, 2 up, and about 1 over. It's roughly 2. It's not exactly 2, but just to get a rough shape of this graph, we see, well, this is what we have so far. So I want to compare this to the actual graph. So I'm going to go back and go to GeoGebra. This is the actual function I used to generate it. We see it's a cubic polynomial. And I'm going to say, hey, GeoGebra, plot the derivative of this graph. And I'll make it green to match our drawing. And we see that at -1, look at that, that's pretty close to 2. And at 6, that's a little bit under 2. So those were our approximations. At 2, we were a little bit off. I had -2. It was a little bit below that. And at 3, I was at -2. It was a little bit below that. So I could have had more accuracy with my slopes at 2 and 3, but I was close. You see that I have a general likeness to the derivative graph using exact functions and derivatives and plotting them precisely. And if we go back to my drawing, we see that we have a general idea of what the derivative graph looked like. So what are the strategies we want to use? We want to first look for horizontal tangents, because where the slope is 0, those will be x-intercepts for the derivative graph. And then we want to look at positive and negative slopes. So I could have done this much quicker without the ruler, without being so precise, just by saying, look, horizontal tangent, it's negative between here, so I expect negative y values. It's positive on this side, it's positive on this side, and we got a real quick approximation of what the derivative graph looks like. The precision of the points isn't quite right, but we would be able to pick it out if it was a multiple choice question. All right, so that's graphing derivatives of functions.